first we need to see the first type, that is going to be second limit x tends to 2 x minus 2 upon x square minus 4. This is what the this is the function, this is the function fx. And if we want to calculate this limit, so what we do directly, we put x is equal to 2. So if we talk about the numerator, then if we put x is equal to 2, then this value, numerator's value, is going to be 0. And if we put x is equal to 2 in the denominator, then this is going to be 0. So the form is going to like this, 0 upon 0. And 0 upon 0, this is what the indeterminate form. We know that this form is what the indeterminate form, and we can use to solve this type of problems with the help of the L'Hopital's rule. Or here, but here what we try to understand, we want to use the tabular and approximation method to solve this type of limits. So this is what we are saying, this is what the indeterminate form. And just what is the tabular method? Let me change the color so that is easy to watch that. Then this is what the table, we just try to make a table, and in that table there is a x and there is a function's value fx. So in that table, what we are doing here, let's see, this is like, if we need to go to the slightly to the near to 2, try to solve with the help of the approximation. We are taking the approximation here 1.9, as this is the lesser than 2. So if we put x is equal to 1.9, the function's value is going to be 0.2564. So we want to go close as possible. So we are going to 1.99. If we put that value in the function as x is equal to 1.99, then the function's value, we get that 2.506. And we want to go as much as we can go to near to the 2. We want to go to, we want to take a little more hard. This is going to be, we are taking the 4 times 9. So here is what we get after putting the x is equal to 1.9999. So this is going to be 0.25001. But we know that at 2.0 the function is undefined. The function is undefined if we are putting x is equal to 2. But we know that the approximation we have taken slightly lesser than 2, and now we get the value as 0.25001. So this is, we need to take from both the sides. This is the from the left side, and now we are going to see the function's value from the right side. Just the approximation, just we are going to take the slightly greater than 2, 0.0001. And if we are putting that value 2.00, then the function's value is going to be 0.24999. So we want to take another approximation, that is 2.01. So the function's value is going to be 0.2494. So by the help of the approximation method, what we can understand here, the value at 2, the value is exactly undefined, what we know according to the limits. But here what we can understand here, that is we can approximate the values from the left and right. With the help of that, we can say that this undefined value is going to be 0.25, and this limit's value is going to be 0.25. With the help of tabular and approximation method, we can solve this type of limits value, which is indeterminate form. But with the help of the approximation and tabular method, we can find the limits value, what the exact value at that so this is 0.25, and now we can say that this is going to be answer for that 2.0. But here what we need to remember here, one thing, like, this is not always possible that the function's value that is f of a is not equal to limit x tends to a f of a. This property we need to remember, like when we are solving the limits problem. This is not always possible. The function's value is not equal to the limit. This is not always possible.